Hi everyone, my name is Aftar Sami and I'm pleased to present our research paper Enhancing Poultry Farm Productivity Using IoT-Based Smart Farming Automation System. Here's the presentation outline that I would be presenting. So in recent years, the integration of Internet of Things or IoT technology has revolutionized various industries and agriculture is no exception to that. This paper delves into the role of IoT in increasing poultry farm productivity through the implementation of smart farming automation systems. First, let me provide some background on the problem we aim to address. Traditional poultry farms face several challenges, including lack of real-time monitoring, inefficient resource utilization, and inability to respond quickly to changing conditions like weather. Certainly, there is curtailing problem which happens due to sudden rainfall. And also, since there is no remote control of electrical appliances like fan, light, etc., they could not take immediate actions. I will now outline some existing related works. IoT-based smart weather monitoring system for poultry farms by J.P. Mondal et al. This proposed system measures temperature and humidity using THT11 and sends alert messages to smartphone and buzzers. So how different we have worked on? They have worked on weather monitoring system for poultry farm, but we would be working not only weather monitoring system for web and mobile, but also automatic curtailing system, automatic feeding and watering system, etc. Next, there is a consumer-grade smart fridge prototype developed by A. Sharma et al. Demonstrate identification of individual food items placed in or removed and estimation of residual food items in container using infrared ray technology. So how different we have worked on? We have focused on many features like the two capabilities of the proposed prototype. But we will be using it on the food part of the chickens and the food storage of the poultry. Finally, there is Clue Farm paper by M. Cloisier et. This paper presents an integrated cloud-based web platform to enable remote monitoring and management of smart farms, leveraging real-time sensor analytics. So our proposed system focuses specifically on smart automation to improve productivity in poultry farms, incorporating sensors, actuators, and controls tailored to poultry environments and production needs. In contrast, the related paper presents a more general smart farm management platform for various farm types. Our key research questions were, first, how effective is the system in bolstering productivity via monitoring, automation, and analytics? Second, what sensors and controls can best optimize conditions and routine tasks? Third, how can the system balance automation with adaptability to handle varying circumstances? And finally, does system deployment translate to higher yields and improved resource allocation compared to traditional techniques? We have several core objectives, including first, improving operational efficiency, second, reducing labor expenses, third, increasing profit margin through cost saving, fourth, enabling precise resource management to reduce waste, and fifth, minimizing environmental impact through optimized utilization of inputs like weather and electricity. In terms of expected outcomes and impacts, we anticipate the system to first reduce labor cost and optimize operational through enhanced productivity and efficiency. Second, improve poultry health by precisely regulating environmental conditions. Third, provide data to increase yields and profitability. Fourth, enable streamlined management via real-time mobile and web controls. Fifth, reduce risk through early warning alerts. Sixth, offer flexible scalability for varying farm sizes. And seventh, promote sustainable agriculture through tech-enabled techniques, and finally lay a foundation for further innovation. Now allow me to provide an overview of our methodology. First, we set up hardware components and configure microcontroller ESP32 and sensors like DHT11 for detecting temperature and humidity, IR sensor for detecting food, water level sensor for detecting water level in reservoir, and rainfall sensor for detecting rain. Then we integrated control mechanism like four-channel relay, servo motor for automatic curtaining for rainfall, web app, and mobile app. And we did some testing and optimizing the prototype model. This diagram shows the overall system architecture with key components. The sensors gather data and feed it to the cloud. The automation controller then regulates the equipments like the curtain based on the configured rules and sensor inputs, and users can monitor or control the system remotely via the apps. For example, for the IR sensor, if there is food inside the food pot, then the supplier would be off, and if there is not, then it will be automatically filled. And if the main food stocks reserve is below 10%, then the alarm will be on, and if it's not, then the alarm will be off. Similarly, things goes for the THD11 sensor. If the temperature and humidity is beyond the normal range, then alarm will be turned on, and if not, then an alarm will be off. And similarly, all of those sensors work similar basis and serves their definite purposes. Next, this circuit diagram illustrates the specific electronic components wired to the microcontroller. The DHD11 sensor, IR sensor, proximity sensors, and range sensors, all of those are connected with the microcontroller alongside the 4-channel relay module and servo motor. Then here are the screenshots of the web and mobile application user interface that we have developed, which is currently showing the current sensor readings and control status. On the back end, our web server aggregates and visualizes real-time telemetry for analysis to derive data-driven actions. And this is the physical prototype that we have constructed. On the left side, it is in the off mode, and on the right side, it is in the on mode when the system is running. In terms of future work, we aim to expand the system by adding the capabilities like temperature and humidity controller, weight and health monitoring of hens using image processing, ammonia gas alarm, which alarms if the ammonia produced from the hen's litter exceeds, automatic exhaust fan to regulate air circulation and remove stale air, automatic litter cleaning which are scattered by hens, and growth data analysis of hens. That covers the key points of our paper. From a small-scale integration perspective, the prototype is made and an insight of the feasibility in large-scale integration and production is studied. Here's the references that we have used on our paper. We would like to thank Intex Research Lab for providing technical supports and giving opportunities to utilize their resources. Thank you, everyone.